Welcome to EDU World Space.
We're asked to find the perpendicular distance between the diagonal AD and the line of action BG, the tension in the cable BG. And in this problem, we've already calculated the moment of the rod AD, the tension vector BG, and the unit vector AD. Since this problem is asking us to reference a separate problem where we've already calculated these values. So to start with, I'm going to first find the parallel component, of this tension vector. So I'll label that as T1, and that's going to be equal to the unit vector of AD dot the tension vector of BG. So that's going to be the unit vector dot the tension vector and that's going to give us a value of negative 64 newtons. So next we're going to find the perpendicular component of that force vector. So I'll label that as T2. Actually, I'll write it out like this. So we have the magnitude of the tension of that BG cable is equal to the square root of T1 squared plus T2 squared, where this T2 is the perpendicular component that we're trying to solve for. So we're given the magnitude, and we've already calculated T1. So by plugging in, we can get 450 is equal to negative 64 squared plus T2 squared under the square root. And solving for T2, we can write it as T2 is equal to the square root of 450 squared plus negative 64 squared. And that will give us a value of 445.4 newtons. So next, we're going to write out the equation that will solve for the distance between the perpendicular distance between the diagonal and the cable. So the moment of AD is equal to the perpendicular tension times the length d. So we know the moment, and we also know T2. So after plugging in, so we plug in, and solving for d. So normally solving for d, it will give us a negative number, but we're solving for a distance of something. So we can take the absolute value. So we can take the absolute value of this moment, and solving for d, it will give us a value of 0.0 0.25 meters.